Hello students, we are going to take up the topic representation of compounds. Right, this topic is from class 7, chapter 4 atomic structure. Children, for the reference, I have used the reference book Connect with Science Chemistry. It is published by Oxford University Press India. It is an interesting and amazing book. Children, you will start loving chemistry once you read this book. Okay, so let's come back to the topic. Now, how do you represent a compound? So, a compound is represented through a chemical formula. So, what is a chemical formula? It is basically an abbreviated form of a compound. So, suppose I have to write calcium carbonate. So, what do? I write calcium carbonate. Every time if I write calcium carbonate, it will become what? Boring, uninteresting task. Okay. So, to make it simple, easy, interesting, what do? I use chemical formula in writing. So what will I write? I will write CaCO3. Okay. Now you need to understand why I have written CaCO3. Why I have not put a value here X, Y, Z. Okay. Or why I have not put a value here X, Y, Z. Okay. So this you have to understand why. Right. So let's take up in detail. Right, so step 1 says for writing a chemical formula, we need to write first cation, then anion. So let's talk about the formula calcium carbonate itself. So in the formula for calcium carbonate, the first part calcium is actually the cation part and the second part carbonate is the anion part. So when we write the formula, what we need to do is we first write the cation over here. I've taken example of calcium. So we take calcium and the second part is carbonate. So we write CO3 2 minus. Okay. Then step 2 says that we need to exchange or interchange the charges of valency. So 2 over here we write as subscript and this 2 over here we write over here as subscript. So next to each part. So Ca2 and CO3 2 here. Okay. Now remember children, if the combination is of monoatomic ions, like here Ca is monoatomic, but over here CO3 is polyatomic. Poly means many, more than one atom present. So here in carbonate you have got one carbon and one oxygen, right? Three oxygen. So this makes what? Polyatomic. So there are two different atoms, carbon and oxygen, forming a polyatomic ion. Then in that case, what do? We use bracket if the valency is 2 or more. So here, over here, the value is coming 2. So what do? We use bracket. Right? Now it says step 4, we exchange the valencies and then we divide by the highest common factor. So over here, the highest common factor is 2. Right, so we divide this and what do we get? We get the formula CaCO3. Isn't it interesting? Now let's take up some more examples. Okay, so suppose I take formula, for writing sodium oxide. Now, what do? First we write the sodium cation, right? Then we write oxide anion, okay? Then we exchange their charges, right? And we write them as subscript. So it will be Na2O1. Since both are monoatomic, we need not to use brackets, right? Then we divide by the highest common factor. So the highest common factor over here, common factor is 1. So we will divide by 1. We get the same Na2O. So this is the formula for sodium oxide. Now suppose I write formula for sodium carbonate. Okay. So for sodium carbonate, sodium plus 1 is the cation and carbonate is CO3 2 minus. What do? We first write the cation followed by anion. Then next step is we interchange the charges. So we get we write as subscript Na2 CO3, we write here 1. Then if the value is more than 1 for polyatomic ion, then we use bracket. But here it is 1, so we do not use bracket. Okay. Now the fourth step says we divide this by the highest common factor. So the highest common factor over here is 1. So we divide by 1, we get a formula Na2CO3. Okay, interesting. Suppose I write the formula for iron 3 carbonate. Isn't it interesting? Iron 3 carbonate. So the cation is Fe. 3 says that means it has got 3 positive charge. Iron 3 cation is also known as ferric. Okay, so this is ferric carbonate. Fe3 plus is cation, anion is CO3 2 minus. Okay, so what we do in next step, we interchange the values 3 here and 2 here. So you will get Fe2 and CO3 over here 3. Okay, then it says if it is polyatomic and there is more than one, then we need to use the brackets. So we enclose this in bracket, then we divide the value by the highest common factor. Over here, the highest common factor is 1. Okay, so 1 is common between Fe2 and CO3 whole thrice. So we divide by 1, we get the formula Fe2 CO3 whole thrice. Isn't it interesting? Now, have you understood why we write just CaCO3 but for sodium we write Na2CO3? So what you need to do is practice. Practice by writing cations and anions and write the formulas. You will start enjoying chemistry. Thank you, kids.